So you are given f of x here and the g of x. Both of these graphs are parabolic graphs. As you can see, the one that I'm highlighting here, it has a said graph. It is the graph of f, and the one that we are having here, g of x, let me just highlight it. It has a happy face. As you know that if a is greater than 0, the graph will have a happy face. So you must know how to differentiate which f and on this graph and which is the graph of g. So a and b are x-intercepts, whereas a and b, here are a and b, the x-intercepts of the graph of f. Then D here is the turning point of the graph of f, and C is the x-intercepts of g. C is the x-intercept of g, as well as what then they say O is the origin. So since O and C, you must know that there are x-intercepts. E and the D that you are having here, they share the x value of the turning point. So that's very, very important for you to know. First of all, before answering these questions, make sure that you interpret the diagram. So D and E here, they share the same value of the x coordinate of the turning point. Since we know here that the coordinates will be x is to y, we know that this x here is equal to p that we are having here. Why? Because they share the same x value, indicated by that dotted or dashed lines, meaning the value of x at E is the same as the value of p at D. I hope you understand that. So let's try to solve 4.1. They want us to write down the coordinates of point F. So you can see that this is point F. This is the y-intercept of the graph of F. So for us to find y-intercept, let's just write our formula as it is on the statement, 15/2. So we know that F is the coordinates of the y-intercept. So y-intercept, you let x to be 0, then you solve. So when you substitute 0 in everything, or where there's x, we have b here, 0 plus 15/2. Then you punch your calculator, you're going to have 15/2. Then that 15/2, 0 is 2, 15/2. So these are the coordinates of F. So they want us to determine the coordinates of C, and you can see that the point C there is the x-intercept of G. So we know that we'll say x-intercept, we let y to be 0, then we know that g of x, it will be y, which is 0 equals x squared plus 2x. Then you do what? You take out the common factor, which is x, then x plus 2. Then you solve for x equals 0 or x equals -2. And you can see that what we are having here, the c is on the negative x axis and O is the origin. 0 is to 0 or -2 is to 0. So this is what? This is O and this is C. This is what they want us to solve as the coordinates of C. I hope you understand this. I hope you understand this, but the most important thing, you must understand your statement and interpret your functions or your graphs. Okay, let's just clean everything. Then they're saying that the turning points of graph F and G are on the same vertical line DE. Then they want us to determine the value of P. We know that the value of P is the x-coordinate of the turning points, meaning they both the graphs, they share what the x value of the turning point. Therefore, we can use the graph of G to actually determine the x value of the turning point by using the formula of the axis of symmetry. So the axis of symmetry is the x value of the turning point. So negative into 2 over 2 into 1. Remember, a is 1, then we're going to have negative 1, meaning that the value of P is negative 1. Therefore, P equals negative 1. Then for us to find the y corresponding value, you take that P and substitute it on the graph of G. So 4.3, they want us to find the length of DE. We do have the value or the coordinates of DE, which is negative 1 is to positive 8. Then where's E? Where's E here? Okay, E is the turning point. So negative 1, we do have the value of P. Then you take the value of P here as it is the x value of the turning point of both the graphs, and you substitute it on the graph of G to find the corresponding y value. So G is to negative 1, where there's x, you substitute negative 1 so you can find the corresponding y value. Negative 1 squared plus 2 into negative 1. So negative 1 here squared, we're going to have positive 1. What we're having here is positive 1. Okay, here we're having negative 1 inside the bracket. Let me just erase it and write it afresh. 2 into negative 1 close bracket. Remember this for substitution. You're going to have 1 minus 2, then the answer is negative 1, meaning that the coordinates of E is 1, negative 1 is to negative 1. Then we do have D up there. Therefore, they want us to calculate the length or the distance ED. Therefore, you can say square root open bracket x d minus x e squared plus y d minus y e. Even if you can say x e minus x d, it's one the same thing. Then you do the substitution. You know that the coordinates of xd is negative 1. So square root open bracket negative 1 minus xe, that's negative 1. Negative 1 squared. Okay, do not forget to put the other bracket before putting the squared, plus yd, which is 8 minus 1 squared. Then everything is under the square root, remember. Therefore, you can use your calculator to tell us the answer. So that will be the distance. You put that, you actually give the SI units as units. I'm not sure if you do understand this, but this is very, very important. I hope you understand what I am doing here. Yes, so let's do the last question. I hope you are following. Please do not forget to subscribe to our channel and like the video. So here they want us to show that a equals negative half and b negative 1. That's what they want us to show. We are proving. So and what you know is that a is in the graph of f and the b is also in the graph of f. Therefore, we know that if we actually write this parabola in this form, we know that p and q, those are the coordinates of d, the coordinates of the turning point, right? Therefore, since it is negative 1, when it comes back to the formula, it will become positive 1. Remember, it will be positive 1 the coordinates of D. So it's going to be a open brackets x plus 1 squared, then we take 8 as it is. But if that one was positive, when we substitute it back on the formula, it will be negative. Therefore, we can use, for us to find the value of a, we can use what? The point on f, which is that f. So when I'm saying the point on f, I'm talking about the point on the graph of f, which is the point f we are having, as it is 0 is to 15. Therefore 15 over 2 equals a, where there's x, we substitute 0 plus 1 squared plus 8. Therefore 15 over 2, we're going to have a plus 8. Remember, this is 2 here, not a. Therefore 15 over 2 minus 8, we're going to have negative half. So this is how you're doing this. Now for us to find the value of b, let's take this a and substitute it back on the graph of f, the one that we're actually using right now. So we'll take that value of a and substitute it on the graph of f. So f of x equals a, which is negative half, open brackets, x plus 1 squared plus 8. Then what are we going to do now? We're going to simplify x plus 1 squared, negative half. Then here we're going to have x squared plus 2x plus 1. When you simplify that, plus 8. Then negative half, you distribute it inside the brackets, it's going to give us negative half x squared minus x minus, not minus, but yes, it's negative half times 1 is going to give us negative half, then plus 8, then you group the like terms. We're going to have negative half x squared minus x plus 15 over 2, because negative half plus 8 is 15 over 2. Therefore what we can say now is that the graph of f equals negative half x squared minus 1x or minus x plus 15 over 2. Literally we have shown that b equals this negative 1 here, then b equals negative 1. Now we are done. So this is how you solve this easy question. So please subscribe.